In this lecture, I'm going to cover most of the remaining properties on the landscape grass type asset that I didn't cover in part 1 of the lecture. Alright, so the next property is useGrid. This is used to specify which kind of algorithm you want the engine to use when distributing the meshes. With this set to true, it will use a jittered grid algorithm, which assigns each mesh to a point on an invisible grid, and then adds a random offset to the location of each mesh. The placement jitter property determines how random this offset is. With this set to the default value of 1.0, the offset will be completely random, which produces the most natural placement. With this set to 0.5, the offset will only be partially random, and you can see that the meshes are distributed much more evenly. With this set to 0, there won't be any offset, and the meshes will be perfectly aligned to the grid. So this could be useful if you're creating farmland, for example, where crops are planted in a grid pattern. Okay, and then when useGrid is set to false, the engine will use something called the Halton algorithm to distribute the meshes, which results in a slightly different look. And so I guess designers tend to use the jittered grid algorithm more often, and so the useGrid property is set to true by default. Alright, so when you have large landscapes, automatic mesh generation can result in huge numbers of meshes, which can significantly degrade performance. So instead of distributing the mesh across the entire landscape, we can optimize performance by only rendering meshes that are a certain distance away from the camera. And we can do so using these cull properties. Cull meaning to destroy. The endCull distance property specifies the distance from the camera at which the mesh will no longer render at all. So right now, this is set too high to notice. But if I change this to say 500, then the grass meshes will only render 5 meters away from the camera and no more. If I change this to 1000, the meshes will render up to 10 meters away and so on. So ideally, you want to set this to a value that is just beyond what the player can see. However, you may need to set this value lower for performance reasons. Okay, and then instead of having the meshes immediately disappear when they reach the cull distance, you can have them fade out before disappearing. But to do that, I will need to edit the material used by the mesh. So I'm going to go back up to the grass mesh property and click on the browse button so I can be taken straight to the asset in the content browser. And then this asset here is the material that this mesh uses, so this is what I want to open. Okay, and then as we can see, this is a material instance, so I'm going to go down to the parent property and click on the browse button there to find the parent material. And then I'm going to open that. Okay, so finally, this is the material I need to edit. So to make this work, I can use a per instance fade amount node. This node will output a texture specifying how transparent each pixel should be, based on a combination of how far away it is from the camera and what the cull settings of the mesh it is applied to are. Okay, so if there's nothing connected to either the opacity or opacity mask inputs, this node can be connected directly to either of those inputs. But if there is something connected, then the per instance fade amount node should be multiplied with it, and the result should be connected to the input instead. So I'm going to add a multiply node to the graph, and I'm going to multiply the value going into the opacity mask input with the value coming out of the fade amount node, and then connect the result back into the opacity mask. Okay, so now the material is set up, and I can control the fading with the cull settings. So I'm going to save this and go back to the grass type asset. Okay, so this start cull distance property can be used to specify the distance at which the meshes should begin to fade. So from this distance to the end cull distance, the meshes will gradually fade out before disappearing completely. This property is currently set higher than the end cull distance, so it won't have any effect. So let's see what this looks like first for comparison. So I'm going to go back to the level editor and angle the camera so that it's looking down at the terrain from a bird's eye view. And then I'm going to move away from the terrain. And when I reach the end cull distance, the meshes will suddenly disappear. But now I'm going to set the start cold distance to 500, which is below the value of the end cold distance. And now when I move the camera away, once I reach the start cold distance, the meshes will begin to fade before disappearing, and so the effect is a little less noticeable and jarring. Okay, and then just like the grass density property, you have the option to override the values of the cold distance properties on a per platform basis by clicking this add button here. Alright, so next is the min LOD property. LOD stands for level of detail, and we'll learn all about LODs later in this section, but for now, just know that all static mesh actors have a min LOD property, and so you would use this min LOD property to override the value that is set on the mesh itself. Okay, and then you have the option to scale the mesh if you wish. And you can set a minimum value and a maximum value, and every instance of the mesh will be randomly scaled between those two values. So for example, I'm going to set the min to 0.5 and the max to 2.0. And now every instance of the mesh has been randomly scaled to between 50% and 200% of its original size. And more variation will look more natural. Okay, and then by default, this scaling property will be set to uniform, which is the same thing as having the lock icon locked when scaling an actor in the transform category of the details panel. So with this set to uniform, you simply set the scale using the scale X property, and it will use those values for all three axes. Or you could set the scaling to lock XY, and that will use the same values for both the X and Y axes while leaving the Z axis independent. Or you could set this to free, which allows you to scale each axis separately. Okay, and then next is the random rotation property. If I uncheck this, you can see that all of my grass meshes now have the exact same rotation, which looks unnatural. So by leaving this set to the default value of true, each generated mesh will be randomly rotated around the z-axis, giving a much more natural look. Okay, and while the random rotation property will rotate meshes around the z-axis, if the next property, align to surface, is false, every mesh will have the same rotation around the x and y axes. More specifically, every mesh will be perfectly aligned to the xy plane. So for example, if I get closer to some of the meshes that have been applied to a sloped surface, and align to surface is false, if we take a peek behind the surface, we can see that the meshes are still aligned the same way they are on the completely flat portions of the landscape. They're just partially hidden behind the surface, which makes it less obvious. But if I set align to surface back to true, then each mesh will be rotated around the x and y axes to align with the slope of the terrain at that point. Alright, so finally, one of the great things about the landscape grass type is that you can actually define multiple meshes for a single type, and define different property values for each mesh. So for example, I'm going to add another index to grass varieties. And then for that grass mesh property, I'm going to use the wild grass variation 12 mesh. So now my grass is slightly more varied, which increases the realism. And then I'm going to add another index and set that to be the variation 7 mesh. But for this mesh, I'm going to set the grass density up to 800 so we can see it better. So now there are these small purple flowers in the grass. Okay, and then if I wanted, I could continue to add meshes to add more variation and increase the feel of a natural wild terrain. Alright, and that will conclude part 2 of the lecture on landscape grass.